Okay, so we're going to go over the open response questions on let's see, January 2017 exam here, and we'll start at number 25. So we're supposed to construct, using a compass and straight edge, the line of reflection. So what we're going to use today is going to be on this one, is going to be, we're going to take the perpendicular bisector. We're going to construct the perpendicular bisector of R prime and R. What that's going to do is that's going to be the line of reflection. That's kind of the definition of a line reflection is the line is the perpendicular bisector between all the pre-image and image points. Now I can't do it on this software, so I'll jump over here. Kind of designed it on Geometry Sketchpad. And this is what it looks like. So what I'm going to do is I'm just going to try to construct for you the perpendicular bisector of R prime. Now what I do is I center my compass tool at R prime. So imagine that we've got our compass tool going. And I'm going to open up to a radius that I know is going to be more than halfway. So watch what happens here. So when I construct that circle, I know that if I construct a circle with the same radius, that these two circles are going to intersect. So I'm going to do that. Center my compass tool at R. That's the radius that I'm going to utilize. And go ahead and draw that circle. Now, these two circles are the same distances from each of their respective points. So we use the same radius. So wherever those two circles cross, we're going to simply use our straight edge, and that's going to be our line of reflection right there. This is exactly what your diagram should look like. You probably don't have to do the full circle, but at least the arcs where they're going to cross. You could have done this with any of the combination of points. So we could have done this with S prime S or T prime T. It's all going to be the same perpendicular bisector. All right, so let's get back here. So conceptually, though, let's write this down. Okay, we constructed the perpendicular bisector of R prime R. All right, so that's what we did, and that should be the line of reflection. Of any segment joining a pre-image to its image. All right. Let's see. Moving on. Get some space here. Okay. For this one, what you're going to want to do is, again, we've seen this before where we describe it. The sequence. Don't just say that you're going to translate, then line reflect, or something like that. Well, let's make sure we don't just say that. Okay. Actually, it's going to be. So when it says describe, let's add some specifics. What exactly is the translation vector? What exactly is the line of reflection? So here's what I did with this problem is I reflected first. I reflect triangle ABC over the y-axis to produce triangle A prime, B prime, C prime. Now those are the specifics that we need. All right, don't just say line reflect. That's too general. You're going to get some points off for that. So let's go perform that. And this is great for showing work. B prime there. And then that's where A prime is going to land. Hopefully you've got a straight edge to use just to look a little nicer. Then that's going to be move number one. Move number two looks like it's going to be pretty simple. We're going to translate, but again, be specific. We're going to translate triangle A prime, B prime, C prime down 2 units. Okay, to produce triangle A double prime, B double prime, C double prime. That should be enough. Some folks like the notation. That's fine. You're going to reflect over the y-axis. Triangle ABC to produce triangle A prime, B prime, C prime. That's going to be move number one. Then you're going to translate. Notation. Translate right or left 0 down 2. Triangle A prime, B prime, C prime to give us triangle A double prime, B double prime, C double prime. All right, that should be plenty. All right, so looks like we've got, this is a cofunctions problem on the open response. Okay, so the concept here that they're testing is what you have is when angles are complementary, their cofunction values are equal. And we've done this on a part 1 before, but this is kind of seeing, do you really know what's going on? So what I'm going to probably do here, just to show the work a little better, is I'm going to redraw it again. And what I'm going to show for work is 90 minus 28. There's 28, or 90's used up. There's 62 left in this triangle. So we're just going to put 62 there. Now, bring this over. Compared to the 28, this side's opposite, this side's adjacent, this side's the hypotenuse. Now, but compared to the 62, this side's adjacent, this side's opposite, and this side's the hypotenuse. So it's a little bit tricky for students to see this in one diagram, so I like to, separate it into 2, and it helps a little bit. So, using this top triangle, and you're looking at, go ahead and write down your acronym. So for this one, if we use sine, it would be sine of 28 is equal to hj, which is opposite, over hg, which is the hypotenuse. Okay? And what that looks like is that's hj over 20. Okay? Now, over for this one, instead, we're going to use cosine of 62 degrees. Okay, cosine of 62 is going to be adjacent, which is hj, over hypotenuse, which is hg. Okay, it's going to be adjacent over hypotenuse. And that also happens to equal hj over 20, because hg is 20. Let's just get rid of that. Shouldn't have a bar above it. It's a value. Okay, so hopefully that's going to be enough explanation. Explain why. Okay, explain. We need to have some words. I don't know if that's going to cover it. Let's see. So I might just summarize this and say, all right, so for angle G, the opposite side is hj. And the hypotenuse is 20. So sine of angle G is sine of 28, which is HJ over 20. Okay. For angle H, the adjacent side is HJ, and the hypotenuse is still 20. So cos of angle H is the same as cos of 62, which is HJ over 20. Okay, for number 28, let's see, tangent AD. Okay. So there's no extra little arc here. That's basically all they're saying in that case. Arc AC is congruent to arc BC. All right, and if arc BC is 152, so then that is as well. And we can figure out what arc AB is. Let's see, we do need that to get angle D, because we need both of these intercepted arcs. So let's do the calculation here. So you're showing your work, even though you could probably do it in your head. It's important to do that. All right, so the measure of arc AB is going to be 56 degrees. All right, and what we have is an external angle. What we're going to do with an external angle on a circle to get the measure is we're going to have to subtract the measures of the intercepted arcs. Then divide that by 2. To get the angle measure. So that's for the exterior angle. Okay, so that's our process. So we'll take 152 minus 56. That gives us 96. Okay, and then we're going to take 96 divided by 2, and that's going to be 48. So the measure of angle D is 48 degrees. All right. It doesn't say to explain, so that should be good enough. It's just a 2-pointer. All right. Now we're going to do a proof here, but again, let's keep in mind it is a 2-point question, so they're probably not looking for a whole lot. Just want a similar. There's no side lengths, so I'm leaning towards we got to get, probably angle-angle similarity. There's one pair of angles, the vertical angles, and right there, GI is parallel to NT. Okay, so that's going to get us whichever pair of angles we want. Okay, if you look here, we've got, I try to teach my students, look for a backwards N, or an N, or a Z, and when you get that for the parallels, right, the inside corners are going to be congruent by alternate interior angles. So we do have it. Now it's a matter of going through the steps here. So first, I'm probably just going to start with vertical angles. So angle, GAI, is going to be congruent to angle, and try to keep it corresponding. It's not critical, but I'm going to go TAN here, and that's by vertical angles are congruent. All right. Next, we're going to use the given. GI is parallel to NT, and that's given. The result of that is angle. You could get away with angle I, because there's only one angle there. And that's congruent to angle N. By vertical angles, now I usually use theorem, but some teachers want you to explain it out, so I will. By vertical angles are congruent when parallel lines are cut by a transversal. So just being safe there, explaining it out. So now triangle GIA is similar to triangle TNA by the angle-angle triangle similarity postulate. Theorem, whatever your teachers have told you. All right. Again, that's only a 2-pointer, so that's plenty for 2 points. All right. Number 30. Okay. So, we've got some key information up here. Isosceles triangle ABC. All right. And then angle bisectors. Wow. So what I like to teach my students here is you've really got to separate the diagram. It's just too complex. There's too much to remember. Let's break down the pieces of it. Let's break this problem down. So AB is congruent to CB, and that gets us these angles right here are congruent. Now, okay, here's the key right there. I missed that. If angle BAC is 50, okay, then that's 50. And, of course, that's 50 by base angles theorem. Whoops. So this is a part where we've got to make sure we show our work. Yeah, you can do 50 plus 50 in your head. You can do this in your head, but again, you should show how you're coming up with 80 degrees up here. If we even need that. I probably don't even need it. Yeah, I didn't need it. I just needed the 50s. So, really irrelevant up there. Okay. Now what we have is, now we're going to take this triangle again, and let's go to another piece of this. You've got a 50-degree angle, and what they're telling us is that this is an angle bisector. So, okay, these are both 25s. And again, you can do this in your head. You never want to take any risks. Okay, that's why. Likewise here, okay, these are both going to be 25s as well. One last diagram we're going to pull apart here. Now we're just going to take this triangle down here right there. Okay. We know these are both 25 degrees. So angle AXC is what we're after. So now we're going to come up here. We're going to go 25 plus 25 is 50. 180 minus 50 is 130. So the measure of angle AXC is 130 degrees. Okay, so just kind of help somebody go through your procedure here. Okay, you're going there to there to there and then back up to here with your work. All right, good enough for that one. Okay, I'm sure this one's going to stump a lot of people. All right, when they give you the letters of the square, G-E-O-M, you need to know that G-O is a diagonal. The order of the letters are critical here, and I saw some of my students do this. So let's go plot it, and I'll show you what I mean. 2, -2 is G. So there's G, and then O is at -4, 2. All right. Now, some of my students assumed that this was the side of the square, but we missed this key idea. Here's the order of the letters, G-E-O-M. E has to be adjacent or next to or consecutive to G. So E could be somewhere over here, could be somewhere over here. All right. Now, here's what we have to know. Conceptually, all right, so concepts we need is all about the diagonals of a square. So we've got to know all the concepts for the diagonals of a square. What are they? 1, the diagonals of a square. Well, first thing, they have to be perpendicular to each other. Second, they're going to be congruent. and third, they're going to bisect each other. All right, to be perpendicular, we're going to need slopes are negative reciprocals. Right? For congruent, you're going to need distances equal. And for bisect each other, this is one that's a little tricky, not used a whole lot, but what we've got to show is that their diagonals have the same midpoint. That's going to cover bisect each other. So the first thing I did with this problem was I figured out the space here. So I've got a 6 crossed 4 up and down. All right, that's going to lead me to a couple things. That's going to lead me to the midpoint as well as the slope. So I'm going to cut those in half. I'm going to go 3, 2. Where do those meet? Right there. M's spoken for, so let's call the midpoint of OG. You know, let's just call it A at negative 1, 0. Okay? All right, so that's a midpoint. Now, the slope of OG, let's see, the run is 6. Let's put that on bottom. The rise is 4, and we can see this, right? It's going down as we move left to right, so that's negative. If your teachers require it, go ahead and use this formula. You know, plug into that, and then you'll still get this. Whether it's 4 over negative 6 or negative 4 over 6 is the same. Let's take out a 2 in both of them, and we reduce that to negative 2/3, right? Now, real simple what we do from here, okay? We're going to have to go perpendicular to OG. So that means we're going to use a slope of negative reciprocal, 3/2. Okay, negative reciprocal of negative 2/3. Okay, so just kind of try to explain that. All right. Now, I'm going to follow this path. Let's see, up 3, right 2. That's going to be too far. It's going to be this point here. Let's continue it. Down 3, left 2. Down 3, left 2. So this is, you know, you're just showing work right here. Now, I know it's going to be these points right here. Okay, and the reason why is because these all have to be congruent. Okay, so I'm going to say A to, I don't know, we'll just go E there. A to E. It's going to be right 2 up 3. So that AE is going to be congruent to AG. Okay, same length. Just to be careful, let's make sure we show that. 2 squared plus 3 squared equals D squared. To talk about length, we actually should show that calculation. Probably going overboard for 2 points, but never want to come up short on this and lose a point. Okay? So then you can see the work below for the lengths. All right. A to M is going to be the same thing. Let's make sure that we get this done correctly now for 2 points. All right, state the coordinates. So let's make sure we do that. Bring that up. There we go. So now let's, we've shown enough work, I think. We're going to say, so point E is now the location 2, whoops, no, 1, 1, 2, 3. So we've got location for E is 1, 3, and we're going to put M at -3, -3 it looks like. So there you go. Hopefully plenty of work there. Use your straight edge and connect those. Okay. And we used all the concepts we needed. All right. Okay. So scale factor centered at the origin. So here's our center of dilation. So here's what I like to use is pre-image times scale factor equals image. Now, several ways to do this, okay? When your center is the origin, you could just take the coordinates and multiply. I want to be careful teaching that, though, because what happens if the center is not the origin? So let me show work as if you're going to do it for any of these types of problems. So what I like to do is I like to consider the change in x from the center, to your point. Now let's take a look at, basically I'm going to call this O. Let's go look at O to R in the x direction. So I count 2 squares, right? So what I'm going to do for the dilation is I'm going to take 2, right here, times the scale factor, 3 over 2, to get the image. Okay, so that's going to be 3. The image is going to be 3. So the change in x for the image is going to be 3. All right, now because there is no change in y, our prime is going to be right there, 3 away from O. So O to R prime, change in x should be 3. That gets us R prime. There is no change in y, so R prime is going to be at the location 3, 0. So I'm going to go through this process. Let's take a look at S. Okay, so here we have S is 4 in the x direction, 6. I know it's messy, but it's to go from O to S, you need a change of x is 4. Okay, change in x is 4. We're going to have to find the images change in x. So it's 2, sorry, wrong number. It's 4 is your pre-image. Your scale factor is 3 halves. So 12 divided by 2 is 6 is the image. Okay? So we're going to say the change in x for the image is going to be 6. Now because the center is the origin, that's going to give you s, the x coordinate for s prime. But now the change in the y direction is 6, so we go through the process again. So that's 18 over 2 is 9. So the change in y for the image is going to be 9. So now we've just located s prime over at 6, 9. All right, so there's s prime. Okay, and last one we're going to do is O to Q. Now I'm going to ignore that it's negative. I'm just going to go in that same direction. I know it's left 2, but let's call it the change in x is still in fact 2, right? So from here to here is 2. So again, we'll just run that quick. The image is, let's see, whoops, sorry, I went upside down here. 3 over 2, not 2/3. That's 6 over 2 is 3. So the change in x for the image is 3. The change in y, also 2. I know I'm doing a lot of tedious little work here, but again, you never want to come up short on these. And then we have Q prime is going to be 3, 3. Wait a minute. Now we got to get the direction correct. It's actually left 3, 3. There's Q prime. So that's negative 3, 3. All right. So now we have it. Go ahead and use your straight edge. Don't do this free-handed, please. Okay. And what they're asking us now is to finish the job. Why are those parallel? Well, dilations preserve slope. but it says use slopes, so okay, they want us to actually go do it. All right, so the slope of Q prime R, let's go measure that. So the change in y, okay, so it's 1, 2, 3, 4, 5. All right, I've got a run of 6, a rise of 3, and it's negative because it's going down as we move left to right. I'm going to take out a 3 to get negative 1/2. Now we've got QR. The slope is, it's like 4. Yep. You get 4 on the run, 2 on the rise, and it is also negative. Take out a 2, also negative 1/2. Now we got to explain it. So we're going to say Q prime R prime is parallel to QR because their slopes are equal. Now, way more than is necessary for 2 points. I get it. But again, we've got to make sure we cover everything. All right, last 2-pointer, regular hexagon. Okay, this is going to be something I'm going to explain quick here. And let's say I just pick any random spot for A that I want. Now, I'm going to put my compass tool on A and open it up so that it passes through O. And I'm going to draw this arc. Now, imagine I have a compass tool, and we're going to get a dot right there. That's going to be B. We're going to do the same process again. Okay, so we put our compass tool on B, open up to hit the center, and that's going to be C, and we're just going to continue around the circle in that fashion. Okay, so once we do that, okay, there's D, and I'm way off. I can see that already. It should have been straight across. So let me go over to Geometry Sketchpad and show this because I can't freehand it. Okay, back over here. Now, let's pick a dot right there. That's going to be A. And here's what I mean. Here's what I was talking about here. I'm going to put my center of my compass tool there. I'm going to pick a radius that has to pass through here. We're going to construct that circle, but let's make it a dotted so that you realize, where is that? You know, that's my work. So you get this point right there. Now put your compass tool there, the center of it, and open up to a dot or a point that's going to pass through this. Okay, so we're going to construct that. Now you can see we get another point. So this is A, this is B, this is C. All right, we're going to start there, up there. And you're noticing that we're just continuing around the circle. I know it's getting pretty crazy, but that's what it'll look like. You don't have to draw the full circles, okay? What we ended up having was, in this case, 6 points that are all equally spaced. So you can connect those. Don't forget to label them. Yeah, it didn't work out so good. All right, but you get the idea, I hope. Go around the outside. Let's try that one more time. Okay, get rid of these. All right, so you can see there's your regular hexagon. All right, the reason this works is you're essentially, if you can focus here on these 3 points, it created an equilateral triangle. And let's get those thick. Okay. So this created an equilateral triangle where that's the radius, right? So this is the same as the radius. This angle right here, this central angle, is 60 degrees. So this arc is 60 degrees, right? Central angle and its intercepted arc. there's 6 of those 60s around 360 degrees. So we definitely proved that that's going to be a regular hexagon, 6 equally spaced points. Now there is another piece, I think, to that problem. Oh, okay. All right, so let's go back here. Let's go back over to Geometry Sketchpad. They want us to connect FB. All right, let's go ahead and label these. A, B, C, D, E, F. Display, we got to label those points. Let's see, yep, we can start A. Okay, they want us to connect F. What was it again? FB to FC. All right, let's go back over there. FB. Let's get back to display here. All right, we'll just get rid of these. Okay, FB and FC. And it's going to connect to make a triangle. All right. Now, what kind of triangle is this? That's going to be a right angle because this is a diameter, passes right through the center point. So that's what we're going to talk about. You can see that, right? So now we're going to come back over to here, okay? And we're just answering this question here. Angle F, I'm going to have to, let's see, it's angle what? FBC. Angle FBC, so it's actually angle B, is a right angle. Let's explain why. It is an inscribed angle that opens or intercepts a semicircle, which is arc F to C. Okay, arc FC is a semicircle because FC is a diameter. Okay. So this is just a fact right here, that it's going to turn into a right angle. But if you need to explain it, we can do it this way. An inscribed angle has a measure that is half the measure of its intercepted arc. Okay, so since the measure of arc FC is 180, the measure of angle FBC is 90. Right, that's that half. Now, angle FBC is a right angle. Right angles measure 90. Finally, triangle. FBC is a right triangle because it's a right angle. All right, so that's plenty. We overdid it on every one of those problems, I would say, but being thorough, making sure it got done correctly. All right, thanks. We'll finish up the rest of them after this.